We hear it all the time, right? Data is the new gold. But let's be honest, raw data is more like raw ore. It's just rock. It takes a very special kind of person to turn that rock into something priceless. And today, we're diving into the world of that modern-day alchemist, the Google Cloud Data Practitioner.
Have you ever had that feeling where your streaming service just gets you? Or your social feed seems to be, I don't know, reading your mind? It feels like straight up magic, right? But spoiler alert, it's not. It's a very, very carefully crafted science.
Yeah, and at the very heart of that science, there's a specific role, the data practitioner. These are the folks who are the architects, the builders, the people who actually put together the complex systems that make all this personalized magic happen for you and me.
So, let's get into it. What exactly is a data practitioner, especially in the Google Cloud world? What do they really do day to day?
Okay, to put it simply, an associate data practitioner takes care of the entire data lifecycle on Google Cloud. Just think of it like a journey. They're there right at the beginning, getting the data in. That's a process we call ingestion, and they follow it all the way through. They clean it, they analyze it, and they even use it to build predictive models and create those awesome visual dashboards that business leaders love. They really are the end-to-end data specialist.
Now, you might be thinking, hang on, isn't that just a data engineer? And that is a fantastic question. It's close, but there's a key difference. The associate practitioner is really a foundational role. They're focused on those core tasks we just talked about. The professional data engineer, they take it to the next level. They're the ones designing the massive, complex systems that the practitioners then work inside of. Think of it like a skilled builder who's an expert at laying bricks versus the architect who designed the entire skyscraper. Both are crucial, but they focus on different scales.
All right, so every data story has a beginning. And for the practitioner, that beginning is all about one thing: getting raw data from wherever it happens to live and bringing it into the cloud where the real work can begin.
And you know, getting data into the cloud is not as simple as just uploading a file. This is where it gets kind of mind-blowing. And this slide just shows it perfectly. Just transferring 1 terabyte of data, just one, over a pretty standard network would take 12 days. 100 terabytes? Try 3 years. And 10 petabytes? You'd be waiting 340 years. No joke. This is the first massive hurdle a practitioner has to solve.
So, how in the world do they get around that 340-year wait? Well, they pick the right tool for the job. For the smaller stuff, they might just use a command line tool, kind of like a text-based interface for developers called GSUtil. For bigger automated transfers, they'll use the storage transfer service. But what about those truly massive multi-petabyte jobs? You can't even use the internet. You literally ship your data to Google on a giant, super secure hard drive called a transfer appliance.
Okay, so once the data arrives, it needs a place to live. And just like you wouldn't store your family photos in a filing cabinet, a practitioner knows that different kinds of data need different kinds of homes. That super clean transactional data from an e-commerce site, perfect for a highly structured database like Cloud SQL. That messier, more flexible data from a mobile app, that might go into something semi-structured like Firestore. And all those raw files, images, server logs, you name it, they get stored in a super flexible object store called cloud storage.
Okay, so the data's in and it's got a home. The next big job is to build the smart plumbing, the automated pipelines that are going to move and transform this data so it's actually ready for analysis. Now, data tends to flow in 2 main ways. On one side, you have batch processing. This is where you work with big chunks of data on a schedule, like running a sales report at the end of every single day. But on the other side, you've got streaming, and that is all about right now. It processes data continuously in real time. Think about analyzing live social media trends or data from factory sensors as it's happened.
So a practitioner has to pick the right plumbing for the job. If they're building a real-time streaming system and they love to write code, data flow is absolutely the top choice. If they're building a more traditional data warehouse and would rather use a visual drag-and-drop interface, data fusion is perfect for that. And what if a company is just moving an old system, say an open-source Hadoop or Spark cluster, from their own data center into the cloud? Well, they'd use Dataproc to make that move as painless as possible.
All right, now we get to the really fun part, the payoff. This is where all that hard work, all that moving and plumbing finally turns that raw data into insights that a business can actually use. It's all about finding that one crucial signal that's hiding in all the noise.
And the heart and soul of analysis on Google Cloud is a tool called BigQuery. The one word you have to remember here is scale. This is a fully managed data warehouse designed to handle petabytes of data. We're talking thousands of terabytes. The size of the data almost doesn't matter. BigQuery is built for it.
So how can BigQuery possibly analyze that much data so incredibly fast? Well, the secret is in how it stores the data. See, a traditional database is row-oriented. It stores an entire record altogether. So if you only need info from one column, it still has to scan through every single row to get it. BigQuery is columnar. It stores all the data for column A together, then all of column B, and so on. So if your query only needs column A, it reads only that column, which makes it exponentially faster and way cheaper.
But here's where it gets really, really powerful. BigQuery isn't just for looking at the past. It actually lets you build machine learning models right inside the warehouse using simple SQL. This is a total game changer. It means you don't have to be some specialized data scientist to start making predictions. Your data's already there. You just pick your features, write a SQL query that says, create model, and boom, you have a working model. It's an incredible capability.
Of course, all these amazing insights are totally useless if no one can understand them. So the final critical step is visualization. A practitioner will use a tool like Looker to transform all that complex data into clean, intuitive dashboards that anyone in the business can understand in just a few seconds.
And finally, none of this works. None of it is possible without a strong foundation of trust and control. And that's where data governance comes in. It's all about managing and securing the entire data landscape from top to bottom.
We can really break governance down into 4 main pillars. First is security. That's about controlling exactly who gets to see what data. Then there's discovery. That's about knowing what data you even have in the first place, like creating a searchable catalog. Third is management, organizing it all logically. And finally, protection, which is like a safety net. It automatically finds and masks sensitive data, like credit card numbers, so it can't be accidentally exposed.
You know, there's a great quote that says, "The goal is to turn data into information and information into insight." And at its core, that is the data practitioner's job. It's to guide data through that exact transformation, turning what starts as meaningless bits and bytes into something that helps people make smart decisions. So the next time your app recommends the perfect song, you'll know exactly who to thank. It's the data practitioner, the person who transforms a world of noise into a single clear signal. So the only real question left is, are you ready to be the one